Welcome to another DSPIRA video. This one is a companion video to go along with the astronomy activity, measuring the speed of the Earth around the Sun using the Doppler effect. In this activity, the students are actually given data from the DSPIRA Horn radio telescopes previously taken by DSPIRA teachers. We can see there's a data set of 6 graphs down here. So this is going to be asking the students to determine the center frequency of these different dates, and then do some math work with that. So the instructions are fairly step by step, but the students still do kind of get a little bit lost in what to do with the graphs here. So I'm going to just run through an example, a video example here, so that we can see what is happening. So we'll just go into a space here. We have a different, this is not one of the 6, this is a different spectrum that was taken of the center of the galaxy from October 29th, 2019. We can see the date right up in there. And the Doppler effect equation that they'll be using is copied here from the activity. So let's zoom in a little bit and figure out what we need to do. So the students are asked to take they kind of chop this peak off right at the 30 line, the signal strength 30. So we'll just come in and get a line, and we will just come straight across here at 30. They'll be using pen and paper, hopefully. So now we need to find that there's this intersection and that intersection, so we're looking for the midpoint in here. So we'll just kind of count. It looks like it's about 1, 2, 3, 4, 5, almost 6 boxes across. So I'll go almost 3. 1, 2, almost 3. So I'm gonna let's just mark that. Let's go in and get a big old brush marker here, big fatty, boom, and that was right about here. So I'll go back and draw a line coming down. So once again, this is what the students could do. So they need to figure out to read the scale off here. So here's a 1420.32. Here's a 1420.34. We can throw a 0 on there. The divisions are 0.004. So 0.324, 0.328, 0.332. Right in here. So let's just write that down. 0.332. Everything's 1420. We'll never get outside that range. So very often we kind of just talk about the decimal. All right, so here's the equation. A lot of the numbers are already fixed. The only thing that they're really going in with each data set is their interpreted number, so they can find the change in frequency. So let's just bring this down into the equation, plop it down right in there. So the 6 data sets that they're going through are going to be fairly repetitive in their nature. They'll just put the different interpreted value in each case and then run through the calculator. So just running through the calculations quickly, 0.332 minus 1420.406, our neutral hydrogen number, equals, and we're going to divide that by the 1420.406 to get a very small number, and then we're going to multiply that by the speed of light, and we're going to get a negative 15.3. We'll squeeze out the 6 out of that, no harm done. Please don't have the students copy all those numbers down. Minimize that. Text box again. So we have a negative 15.63 kilometers per second. That negative is very important. That's indicating that it's a redshift. So that means that at this particular time that we should be heading towards the center of the galaxy. We're getting closer. The distance is closing in, straight out of definition of redshift. Hopefully you found this quick little tutorial video helpful and help the students get through the process. So until next time, enjoy.